Hey everyone, and welcome back to Ben's Almanac, the only show where you can watch it being built as it's being built. Each week I document the process of creating our full presentation builder on the way to building the show itself, the tools, the experiments, and the lessons we pick up along the way. This week we're diving into a phrase that keeps popping up in my notes and conversations lately, something people have started calling vibe coding. It's a loose term, but it says a lot about how AI is quietly changing what development feels like and how people are actually reacting to that, especially that get impacted the most, like in the tech fields. But let's jump into it and we'll start with a quick recap. Last week, I dived into the story crafter, which was a test I ran for handling simple LLM workflows. This was to showcase how LLMs are getting used and to serve as a foundation for what's coming next in terms of terms and things like that. Together with the work from previous weeks, including the architecture done for the repo, the repository, or the folder structure that holds a project, the intended design having been documented, and the LLC structure in place on the more organizational side, it means we finally have a professional foundation to build on, or in other words, the scaffolding's here, and so now it's time to actually work inside of it. And while I was organizing the repo, I kept running into this pattern. The way people are coding with AI tools now doesn't fit with traditional labels anymore. There's a lot of historic use of auto-completes and toolings, but the integration of LLMs into the process is a lot more holistic on how it's working now. And you'll hear someone say they're vibe coding, meaning they're not meticulously planning each step, but working with the AI or the LLM more specifically in a sort of creative feedback loop, and also being used as a bit of a tongue-in-cheek term by software engineers in the wake of tech layoffs, as lower skill coders can match some of the traditional work of that field. Although it's not to a major extent, in my opinion, having looked into that somewhat. I think the layoffs were more caused by overexcitement of software engineers getting higher than previous years. There was a couple companies that were really investing heavily into that, almost as a precautionary measure, and then other companies followed to make sure they weren't losing out on all of them, and then that created almost an oversaturation in the market. But that's my view from a more business lens perspective, that the AI boom as it is was more a catalyst here than necessarily a cause. And in a lot of ways, even though the use of LLM tools for coding has made it much easier for a lower technical skilled person to enter that field and make more impact, especially for their own and smaller projects, as those projects build in size and complexity, and they get absolutely huge at these big companies. LLMs just aren't really equipped to replace that kind of labor at any sort of scale right now. But they are absolutely incredibly useful if you want to do smaller or personal projects or have something targeted in mind. And so that makes them great for my use case. And as I started mapping that idea out, I found that there was 3 clear levels to it from what I could see. Now, the terms I'm coining here for the levels getting used are in the parentheses in the blue boxes along the top. That's the micro, the mesa, and the macro. And we'll get into it in more depth, but it's the really small, the kind of medium-sized ones, and the really large ones. And that's kind of what you want to have floating around in the back of your head as we're talking about it, is that they're all the same kinds of models on the back end, but where they're applying their focus differs pretty significantly. And to start with an example, we'll look at the micro. And that's where you have things going on in this command line shell. And a command line is, on a Mac, it'd be something like the terminal, but it's basically your computer's lowest level of interaction in a lot of ways Whereas a lot of times if you want to open a file or edit something or open an application or use it, you might, find the application, you might click through it, you might go through a folder. But every time you're doing that, you're using something called a GUI or a graphical user interface. And, it's designed to allow you to interface with something visually. But your command line allows you to do that much more directly with the computer. You just tell it exactly what you want to do with some code. And some people use that extensively, some people use it less so, but when you need to use it, it's really useful. And integrating an LLM into that directly creates a very low point of activation energy to use it and figure stuff out. And so Claude Code came online, I believe around 8 to 12 months ago was its first version release. And it's really great at testing things quickly for logic exploration, has really low friction, it's a fast feedback cycle. But the cons are that it has limited persistence and context memory, so you need to call it up each and every time, refeed it back to where you want it to be on your computer based on what your working directory or the working folder of information is. And it gives you less precision on dictating exactly how you want that model to interact because it's a lot of proprietary software on the back end. And then finally, it's actually pretty expensive as far as these models go because the API usage for models for most use cases gets really cheap. But with things like Claude Code, you have the normal API use charge. You have the stuff on top of that because it's, a specific product of that company as well, to my understanding. And then you also have a tendency for these models to try to load as much information as they can because they only have so much information they can have at one time. But if your project's small, they might take all of that. And then they process all that information. You get charged for that every time you do these individual runs. And there's ways to get it down, and they have like clever context management strategies. But on the whole, this tends to be feedback I've seen quite frequently online that Claude Code is really useful, but it can be pretty expensive. And then you have this meso level, this middling level. And this is where you have things like your text editors, such as VS Code being one of the most famous. And at that level, you manage projects and write your coding in it and whatnot. You use your Git, you pull, you clone, copy, whatever you're doing. And at this level, you can also integrate the LLMs, and they get more bound to whatever that specific project is at a particular time. And you can call things such as Microsoft's Copilot, which uses Chat's GPTs on the back end. And you can do a lot of similar things, but it more tends to be designed around the same workflow used in that autocomplete cycle historically, those tools for software coding and engineering, where it's less a full interaction directly with your project and more looking at like a targeted execution or fix of a solution. And this makes it ideal for daily use or production use for people who are professionals in the field. And it's also a smaller transition to using this when they're already used to help coding and other things. But it allows for some nifty tricks where you can refactor your code, which is basically like making a new draft, something more polished, much more quickly and as you're working, and getting more suggestions in real time and stuff like that. So you could think of this as like traditional tooling, but on steroids basically. And this is that middling level where speed meets structure. And finally, you have this macro level, and this is what I'm more traditionally familiar with. And it's also a lot, it's a bit clunkier, honestly. And what you do is you go to your ChatGPT or your Anthropic site, and you would have in those like conversational logs that you might see used where you normally type something. On the left-hand side, there's usually some little plus button. And you'd click that plus button and then you'd say add files. And you take a zip, which is basically when you have a folder of information, and then you compress it for memory storage purposes. And you drop that zip in and it opens it up, and then it can see all of your structure. And this makes it really useful for refactoring that drafting, for documenting, for audits. You have like a fixed use case, you know exactly what you're pulling from, and then you can question the system. But it's also slower for your iteration speed, and it has a higher level perspective. There's also the back end being used. Again, this tends to be something like RAG we discussed last week, but it's limited by the hosting company's designs and exactly how they're employing that. So I think we're going to see less development here as we would with some of the other use cases, because the friction of having to drag and drop your files each time, I think, makes it less ideal for professional workflows, even if it's really helpful for smaller enthusiasts or hobbyists who just want to work on one specific project, a week apart, just making these little enhancements. For that, it's a pretty good use case. But across all of these, the really small, the medium, and the big, all of them tend to be converging in terms of their functions and what they can actually do. And so we're seeing a sort of integration of these ideas into what I think will emerge as an almost professional standard. Because they're all capable of seeding the broader repo so long as you feed them the files. It's just about how you're doing it and how easily you can switch that to a new thing you're feeding it. You can ask questions over that information so long as they're all set up to read all of those files. And it can assist you in writing or directing your repo changes, scripting up new things, making a new draft of some code, all that sorts of stuff. But each and every one of them have the Achilles heel of being constrained by their context window. And as a reminder, the context window is like how much these LLM models just intrinsically can see at one time, because they can only get so big. You can think of it like how much they can see in their field of view, but they can only ever see one snapshot of a visual. That's the trick with LLMs, is they're always one-off. And the reason we can give them this almost persistence is a whole bunch of tricks on what is inside that shot at one time. But when you're doing things like coding, there is a lot of things that you can't see, or slight considerations that come up, and making sure that gets fed into the model when you're asking a question, or it's rewriting some piece of code or whatever it is you're trying to do, can be really tricky. And that ends up being what I think the greatest bottleneck for this actually expanding into really taking over software engineering jobs. Is it's just really hard to configure a model to see all that information and to take into account all of the various ways things can go wrong, or the states, as the term is used, in some of the pieces of the software itself. And we have solutions to stuff like this that allow us to take that context window and use it way more effectively. We talked about that somewhat last week with RAG, but there's also stuff like GraphRag, which uses the same approach of turning words into numbers, the vectorizing. But then it basically uses something like a Wikipedia system, where part of every piece of information you tie it to like hyperlinks, like the links you'd see on a Wikipedia page. You basically do that with pieces of information, and it allows the model to pick all the pieces it thinks will be useful before you do something. And then you have the more classical use of just really good metadata tracking, which tends to be really tedious and slow, and so corporations don't always do the best with that. But the flip side is, with LLMs, it's a lot easier to write and include and update that documentation as time goes on. And I think that will be one of the biggest ways we see information getting used and like helping the process of actually building these things, is that just the simple use of LLMs to ensure the documentation is always up to date, I think will end up being an absolutely huge breakthrough and create a lot less headaches for everyone. But overall, I think a new professional working standard is going to be expected, and will converge based on how exactly all these context retrieval best practices evolve. And what emerges from this is just like the empirically best version. because people don't know what the best way to use this stuff is yet, and the only way we're going to find out is by testing and actually interacting with it. So next week, now that we're done with the main part of the presentation, just quickly go over next week, and that is going to be diving into some friction point and decision point that we've been making during the early implementation of the story builder. I haven't decided which one yet. I think it'll be something about the trade-offs I need to make on the design of a slide and what can actually get included on it in a way that's repeatable versus making sure it hits the minimum standards of professional polish. I need to actually put it out there into the world, at least consistently, if we're going to use it as a baseline. But we'll go over that loop of decision to friction to documentation back to the start, and we'll look into it in more detail next week, going from theory to applied testing. But anyway, thank you everyone for coming today, and I hope you enjoyed the show. See you next time.